everyone! Just over 1 year ago, we launched Epic MegaGrants, a $100 million program to accelerate the work of talented teams and individuals working with Unreal Engine, 3D graphics tools, and open source software. We are happy to share that to date, more than 600 remarkable recipients have been issued MegaGrants, totaling over $42 million in financial support. As part of the program, we've also earmarked 129 Magic Leap 1 devices for recipients, and now we are thrilled to welcome AMD, who has introduced their support with the generous contribution of AMD Ryzen 7 3800X desktop processors, eligible for giveaway to Epic MegaGrants recipients. Head over to the Unreal Engine feed to see a selection of projects included in the latest round of MegaGrants, and visit unrealengine.com/megagrants to apply. We're excited to announce the launch of The Pulse, a new series of interviews and live Q&As that will uncover emerging trends in real-time 3D. In the first episode, David Basolto, founder and director of ArchDaily.com, will lead a panel to discuss how real-time tools are transforming collaboration in architecture, engineering, and construction. Learn more and register for our upcoming episodes at unrealengine.com/thepulse. Unreal Engine 4.25.3 is now available on the Epic Games Launcher and via GitHub. See the full list of fixes on our forums, then update to take advantage of these changes. Hit Apple Arcade title Spyder is the latest entry to emerge from Sumo Digital's internal game jams. In preparation for an official launch, it was time to rebuild the existing blueprint-based prototype in C++ with the intent of making it more characterful, maintainable, and performant. Get a walkthrough of the animation and movement systems for Agent 8, the game's many-legged protagonist from Sumo's own programmers. After an impressive showing for Unreal Engine developers at May's Inside Xbox event, an array of Unreal Engine-developed games for Xbox Series X were shown during Microsoft's highly anticipated Xbox Games Showcase. From world-bending thrillers to the return of an award-winning franchise, check out the Unreal Engine-powered games that took center stage during the Xbox Games Showcase. To prepare students for successful careers in visual effects and game development, the Dave School encourages collaboration, iteration, and problem-solving under the same demands of real studio environments. Offering 2 tracks in VFX and game dev, they recently collaborated to produce Deception, a short film developed by the school's students and faculty using virtual production techniques and Unreal Engine. View more of the cross-discipline project and see why they believe that real-time is a game changer. Speaking of student work, there's only 1 week left to submit for a chance to be featured in our Fall 2020 Student Showcase. All submissions are due by August 5th. Head over to the feed for full details on how to submit. And over to our top weekly Karma earners, many thanks to Clockwork Ocean, Every Nun, Faded Ex Nova, Evil Cleric, Napik Zadam, Jazdella, Shadow River, Chur, and Prince Latte. Jumping over to your beautiful community projects, this unique spotlight is Rachel, the world's first fully automated, autonomous 3D design influencer on Instagram. Designed to create likable images, Rachel's been posting 1 new image per day since May and will continue to do so without any human intervention, as long as the computer she is running on is online. Find out more about Rachel and creator Matthias Winkelmann on their website. Inspired by the fantastical worlds of Studio Ghibli, real-world Havana, Cuba, and the bustling markets of Thailand, the Scavenger's Colony is an exciting miniature environment created by Arnaud Cladet, a 3D environment artist studying at Rubica Soup Infogame, France. Watch Arnaud's full showcase and see more of the incredible figures used in the piece. And lastly, play as Cassie, an intrepid scavenger seeking salvage in abandoned mining facilities in the narratively driven puzzle platformer Sky Beneath. Embark on an adventure with your inventor friend Annie, take control of gravity, and solve challenging puzzles in a mysterious sci-fi setting. Find out more on Steam. Thanks for watching this week's news and Community Spotlight.
Hi everyone and welcome to Inside Unreal, a weekly show where we learn, explore and celebrate everything Unreal. I'm your host Victor Broden and my guests today are Jeremiah Grant, product designer, welcome to the stream, as well as Helge Matthey, senior engine programmer. Welcome you both. Today we are going to cover a little bit about how to animate with Control Rig. Would one of you like to give a brief breakdown of what a Control Rig is before we get started?
Yeah, so Control Rig is a node-based rigging system. It allows you to animate in Unreal, create procedural rigs, and drive them in various ways. So real quick, what we're going to go over today, we're going to go over what Control Rig is in a bit more detail, show you some little micro lessons of little features you can do in Control Rig, and some of the new features that you'll find in 4.2.5. And then I'm going to go over the Control Rig Mannequin sample. We put this on the marketplace just a few weeks ago, I think. And I want to dive into a little bit more, talk about why we did things the way we did, and how you can expand it yourself. Then we'll talk about animating with Control Rig. This is using Sequencer, being able to create content. We'll start with this Control Rig Mannequin example, and how to use that animation in your own gameplay. And then runtime rigging. We haven't talked about this much in a while, but we're going to explore this a little bit, creating procedural motion and using that in your anim blueprints. And then we're going to give a sneak peek on a couple things that you can expect from 4.2.6.
Sounds exciting. Let's get started.
Yeah, so Control Rig, as I mentioned before, it's a node-based rigging system. You can build animation rigs with familiar functionality that animator may be used to from a DCC like Maya or Blender. We can see the example of a Control Rig here. In fact, this is the same mannequin example that's available on the marketplace now. You can expose those controls to animators, or you can expose them to gameplay. You can create really cool procedural animation, and we're going to show a few examples of that pretty soon. And one of my favorite things is Control Rig is accessible through Python. You can create scripts to automate your workflows or augment your pipeline. So I'm going to jump into a couple micro lessons here. I'm going to show a couple things in 4.2.5 that I'm pretty excited about. And yeah, let's jump right in. So first off, let's look at this mannequin here. I have a quick setup, and I'm going to use an aim node. First off, I should probably talk about this editor in general. This is the Control Rig editor. We have our viewport over here. We have a rig graph, which is a start node graph, and rig hierarchy and execution stack. So you can see in our rig hierarchy, we've already imported our skeleton. We'll talk a little bit more about how to create a Control Rig later. And all I'm going to be doing is manipulating some transforms. So I have a begin execute, which is where my graph begins, and it's flowing right into my aim node. This is very similar to any other blueprints that you'll see throughout the editor. So in this case, I have an aim node, and the very first thing I want to show you is a new feature 4.2.5, which is control pin value. So normally you would have to type in a value and move my head around, and it's kind of slow and cumbersome. But now I can right click on this pin and say control pin value, and you'll quickly see it created a manipulator in the viewport. I can drag that around and you see my head responding. And you see the value updating in my target and my aim. So next, let's kind of take that to the next level. I'm going to add a couple vectors here. Let me just connect this up. And you'll see now I have a few things showing up already. So let's talk about those. First, you might notice there's some weird pins on this add node. And what those are showing is that there's some debug information or some embedded nodes inside these pins. So we can see this green. If I right click on this result pin, you'll see there's a visual debug. So let me just go ahead and remove that. In fact, I got a couple of them in here. So let me right click on here and add visual debug. We immediately see this line turn red, which is saying that there's a node embedded between these two pins along this path. And our details pane shows the details for that embedded pin, or that embedded node. It's got a couple of parameters here. I'm just going to change the color of it to green. Great. And since I'm adding values here, I'm able to make adjustments in multiple ways. You also noticed when I connected those pins, they updated immediately. The results in the viewports appeared immediately, and that's because we now have auto-compile in 4.2.5. So you don't have to keep going back and manually compiling every time you make a change to your graph. So let's go ahead and take this value from my pin A, and again, I'm going to go to the control pin value. See, I can move things around. So let's look over here, and then maybe I want to manipulate this again, and I can adjust. This switches down to origin, and just adding those values together. Now, if I take this again to the next level, I'm going to add in a sign so I can look back and forth, still adjust my head movement. This will be really helpful. Let's say if I have just kind of a scanning thing and I want to adjust where that camera is scanning, for example. So I'm just going to hook this up to my second add pin. You can see it's barely moving there. That's because my sign is between -1 and 1. So I want to highlight another feature that we have. I'm going to right click on this sign pin, and I have add interpolates. So this is very similar to some of the alpha settings you may see in Anim blueprints. I can do mapping, map ranges, I can clamp my results, I can interpolate so I can speed up or slow down depending on which direction the value is going. So in this case, I'm just going to map the range from -1 to 1, which is my incoming from my sign. And we'll do something reasonable like -30 to 30. So now you see my head scanning back and forth. It might be helpful, though, to see this value. So I'm going to go ahead and add another visual debug, and I can see where my head is aiming, and then add it on this procedural movement. So now if I right-click on this pin, I go to my control pin value, I can look around and quickly see my character with its procedural motion and my art-directed motion. So
I want to point out one thing, Jeremiah. Actually, can you zoom in larger than what we can see on the screen right now? I think with holding control or something, you can zoom larger.
In my graph?
Yeah. So first off, I'd like to highlight that they're not weird pins. They're bugs. Look at them. They're like tiny mini bug icons. That was supposed to look like anyway. So either hollow, soulless, or with a soul. Anyway, so one of the things that we added here is not necessarily just bug and interpolate, but the notion of what we call an injected node. So really what's going on here is that where you see these bug icons on the pin, there's a node hidden, right, that you can edit. If you go on the edit interpolate, you get to the details panel of that node. What you can also do, though, is you can actually bring out the node to the graph. So if you right-click and click on eject, it takes that node out of the pin, so to say, the hidden node, and now you can see the settings you have on that node are the same settings that you saw earlier in the details panel when you chose edit, interpolate, or whatever it was. The reason I wanted to highlight this is that you can learn about these nodes that way, and you can use them separately as well for other purposes, right? And the visual debug is the same. The visual debug is actually a node that, as the value is going through it, draws it on the screen. And because you do this so many times, we decided to have a workflow where it's hidden in the pin, but you can always bring it out to look at that node. And you can use it for other purposes as well if you want to.
Yeah, exactly. It has been really helpful for us when we're creating complex rigs to see a point in space, maybe a pull vector, or interpolation. I really like having consolidated graphs, so I like having these pins or these nodes injected in the pins. Right now, we don't have the ability to re-inject that pin. So once you eject it, that's kind of where you're stuck. But it's a quick way to see what's going on, explore what we're doing under the hood on each of these, and just to consolidate your graphs. So I'm going to go over.
I didn't want to say anything, sorry.
I'm going to go over to my next little example here and just talk about a couple more things that we have in 4.2.5. Here I'm going to be using distribute rotation and a vector 2D control. So I already created this control. I have this available here. And one thing you may notice if you've used this before, we now have limits available. They're both visible and editable in your details. Now I've set up this graph so when I move this control around, it's limited. and rotates my my neck and my head bones. And the way I'm doing that is I'm just giving my vector 2D and I'm multiplying that value. So right now it's set, it's limited to -1 to 1, and then multiplying it by 30. But I could just as easily use a remap or an evaluate curve to adjust the way that this behavior occurs. In this case, this was just the easiest way to do it. And then I'm converting that to a rotate from my distribute rotation. One really cool thing about using these nodes like distribute rotation instead of just setting transforms directly is that you can do things across a chain. And so in this case, I could have it just on the head, or I could have it on the spine. So let's go ahead and take a look at what this looks like if I do the entire spine. So now really quickly, I'm able to get some quick motion across my entire character using a single 2D vector. This could be additive as well. So if I wanted to have full FK controls between this and then do an additive distribute rotation, I could do that. You have all the control you want by using math nodes and processing in a stack. In fact, let me just point out here that we have this evaluation stack. You can see directly the order these executions are happening. So if you wanted to create a more complex art-directed behavior and then layer on procedural motion, you can define the order that happens. And so one last thing I wanted to point out, on controls, we now have this animatable flag. And that allows you to create controls just as a rigger to determine, let's say, debug scenarios or complex procedural motion that's driving controls and then driving bones, but you don't necessarily want all those controls showing up in sequencer in your rig. You can uncheck that, and those only the controls that you want to expose are exposed in sequencer. With that, I'm going to hop over to Helge. He's got a few things to show as well.
Let's see if I can figure this out. So does that work for you guys?
Yep.
Great. So I'm actually going to go ahead and create a control rig from scratch, and then we'll jump to prepared assets. I might, depending if I get stuck, I might jump to the prepared assets anyway, but I want to show you how you get started. There's a bunch of different ways you can do this, and I'm going to go with the simplest way, I'd say, in terms of UX, and that is creating a control rig off a skeletal mesh. So what I'll do is I'll enable the skeletal mesh filter so I can see the skeletal meshes in this project. And I'm going to right click on the mannequin. And I'm going to say create a control rig. That will set up everything for you, so you don't have to do the steps manually. So if you do that and you look for the control rig that was just created, you can see what this has done. It actually has done a bunch of things. And you can do all this manually if you want to. It's imported the hierarchy. So it's imported all the bones of that skeleton into the rig hierarchy view. Also, we have another view, which is called the curve container, which contains all the curves. So in this case, it's imported those two curves as well. And it's done another thing. It's actually set up the preview scene for the editor and use this skeletal mesh as well. So it seems obvious, but now what you have is you have the hierarchy and you can see the particular skeletal mesh over here. The reason that that's sort of a setup phase or a setup step is because control rig is actually independent from these assets completely. It has its own hierarchical representation, and you can change the preview mesh at any time. Currently, in this version, the topologies of those skeletons have to match, so to make it work. But what's nice is if you have slightly different characters or you wanted to try it on different meshes that share a skeleton, you can switch those. So if you hit compile, I'm actually going to choose one option here, which is draw all the hierarchies. So you can see all the bones in the editor. And then I'm going to start building up my demo. So the first one will be, in preparation to this, we got a lot of questions around, are there IK solvers? What kind of IK solvers are there? So I'll try to cover 3 of them in this particular example. And bear with me, it's a very simple example, but I want to take my time to sort of show you all the steps. So first off, I'm actually going to create a control for my IK solver. So I'm going to right click in here and say, create a new control. You can also do that using Control N. And you can see it's born this control down there outside of the hierarchy. And I'll call this hand left control. Next, I'm going to move that control to where my hand is, so somewhere here, right? And I'm going to use this, the contextual menu and say, set its initial transform to the closest bone that you find. So it's going to snap it onto where the hand is, and it's going to change its initial. So let's look at the details panel so you can see what I mean. So the initial of this control now is set to where the hand is, which means if I move it anywhere, and I hit Control G, or I right click and say reset transform, it's going to snap it back to where it was. So this is sort of the zeroed out transform for animation purposes, right? This is where you would start with the animation. So in this case, for the hand, that's correct. Obviously, for a larger elaborate rig, you wouldn't just have this in global space. You'd probably have the controls parented to each other. You'd have a main control, a pelvis control, whatever you need. But for this example, we'll just have one. Next, I can bring in my control to the graph and read its value. So I'm going to say get the control in. This is going to set up a node for me, setting the right control to read, and then you have access to different things here. So we're interested in a transform, but you can also, in case this had limits, you can also get access to minimum max of the limit. And then I'm going to set up an IK solver. So I'll just pull out the execute. You could also right click and type in IK. And you can see we have a bunch of different ones. I'm just going to focus on the first three, and actually it's going to start with the most simple one, the 2-bone IK or basic IK. Next, we have to sort of pick what bones do we want to use for this. So I'm going to choose upper arm on the left side and lower arm on the left side. And for the effector, I'm going to use the hand on the left side. And you can see that it now does something. Obviously not the right things. This looks pretty screwed up. But let's look at what is happening. Basically, what's happening is that our effector, which is this port, is at the center of the world. So it's pulling the arm down. Also, because I don't have this flag enabled called propagate to children, it's just moved these 3 bones, but all the nested bones, like the fingers, are still in place. So I'll just click this, so you'll see the whole arm is now being pulled down. So that's better. Next up, we could use the feature that Jeremiah was presenting, which is control pin values. We could do that and then move it up. But instead, I'm actually going to plug in my control. So now you can see it's solving the arm, but there's still a couple of problems, and I'm going to fix them as I go. First of all, there's what's called a pull vector in this thing. And that's used to define the 3 points of the triangle. So we start with the upper arm, the root, the effector, and then the pull vector, which is currently probably at 0 or 0 or 1 or something like that. So I'll change it. I'll change it to be a location, and I'll put it somewhere else. So if I go ahead, and what I'm actually going to do is I'm going to use a point which is nested to this control. So I'll make an absolute out of this, and I'll use this control as a parent, and then I'll move it in the control's axes like Z a bit backwards and at negative X. So I'll do like, I don't know, 30 minus 10, and then I'll wire this into the translation of that result. I'll wire into the pull vector. So now, if we rotate the hand, for example, we can see how the pull vector is also turning. Again, this might not be necessarily the right solution, but for demonstration purposes, that's what I'm going to use. And you can visualize this as well by adding visual debug to this. So you can now see where that point is. So you can see it. This is what I'm currently using. Not ideal, but we'll leave it for now. You can also see there's some other problems here. So you can see how these bones aren't aligned correctly. You have some options for this. So the secondary axis is what the roll is used for. So the primary axis is where the bone is pointing along the chain. And the secondary axis is what's the axis that needs to point towards the pull vector. So this is incorrect. So I'll change this to negative y. And there we are. So now we have our basic IK set up. And now we can go ahead and start looking at some of the other IK solvers that we have. So for that, I'm going to go over to the prepared asset that I have set up already. That looks very similar to what we just built. So you can see this is what I was showing you before, basic IK, make absolute and whatnot, the hand control. Down here, we have some other IK solvers. So we have the fabric, which is forward and backwards reaching inverse kinematics. And that's a solver that can use more than 2 bones. It can work along a longer chain. So what I've done is I've set it up to solve from the spine, the first spine bone, all the way to the hand. And then down there, we have yet another multi-bone solver called CCDIK. It's going from spine 1 to hand as well. This has some more settings around rotation limits and other things, but we're not going to go into too many details of that at all. I just want to show you that we can switch between those here. So what I'm going to do is I'm going to pull the hand to a location that's sort of bringing the character into an interesting pose, maybe to pull it down a little bit. And you can see how the fabric solver is actually giving us this sort of solve along the spine. You can see how I can pull him a bit more like that. Whereas if I pull this back up here, you can see that obviously the basic IK will just go like that, and that's it. I can't do more because it only solves these 2 bones. So we have fabric, and then having a setup like this, where you can sort of leave the control, rely on autocompile to change the rig as we go, but keeping the control where it is. It's actually kind of interesting to just switch between and see the different solves. So this is CCIK, has a slightly different sort of passive reaction. As you can see, he's already leaning to the side, even though I'm pushing just a little bit. If I go over here, you can see fabric solves very differently. So this gives you an opportunity to sort of test for different parts of the body. You can test the different solvers. You can blend them with each other, obviously, and can choose the right algorithm for the right job on each body part, and even along your animation. Next up, we're going to look at spaces and controls. So if you already used controls a little bit, and I'm going to try to cut this short, but we had the question a lot of times in preparation to this, which was, what's the difference between spaces and controls? Why do you even have the two? So controls is what we've used so far. Controls are objects you interact with and you put animation on. They're usually visible. They don't have to be visible, but they're usually visible in 3D. So they'll be your dials you click on and move. Spaces, however, are intermediate transforms that you can use to organize, to offset controls. And spaces can also relate to existing objects in the tree. So in this scene, what we have on this rig, we have 2 spaces which are nested below bones. So one is this hand left space that's below the hand left. And then we have the same thing on the other side. So here's hand right space, and that's under hand right. And then we have a third space, which is at the top of the hierarchy, which is called hand center space. And below that, there's a control. So there's actually a control here. You can't really see it. It's in the body in there. And then we have a little graph. And what that does, it takes the left-hand space and the right-hand space, interpolates the two, right? And then sets the center space. So I've just, for simplicity's sake, I've just set position. And then what that means, if we add a procedural animation here, like if we add an animation clip rather, for example, I don't know, this guy, where he's sort of hovering in midair, you can see how this space where the control is parented in is now between the 2 hands. And I can still use this guy for animation purposes. So now I have a control space, which is procedural. And obviously, you can change the settings. You could set this to be 0.2 or something, interpolated between, and I could go ahead and, I don't know, wire, like Jeremiah was showing, wire a sine wave to this, right? And then you would see this guy go back and forth, and the control is unchanging. It's the space the control is in. Oh, this is going to -1. Anyway, you can sort of see how this is going over, interpolating, and this is what you would use a space for, right? Not only for hovering transforms like this, but for anything where you have to relate controls to bones or other things, or where you need intermediate transforms that you want to procedurally set and drive. So that's what spaces are for. Anything to add here, Jeremiah? Any comments?
No, I think that you pretty much covered it. Spaces can be really useful for both offsetting transforms. You can also nest controls under controls. You have options to do either. This type of scenario that Helge is showing here is maybe creating some sort of weapon system. If you want to have a weapon bone, you want to be able to control procedurally which hand that attaches to or attaches to the back, for example. Spaces can really help you out there.
Yep. All right. So next up, the next one that is also based on some questions we got is squash and stretch. So this is not an elaborate squash and stretch setup, but I wanted to take a try at this and see what we can get to. The quick answer is yes, you can do squash and stretch. You can do it in multiple ways. What I've decided to do, though, is showcasing some of the other nodes that we have. So in this example, I can pull the head up, and you can see how this is sort of creating a stretch and a squash. Again, I wouldn't say it necessarily well art directed, but what's interesting also, we also have sort of this IK spine alongside. And the way this works actually is multiple phases. So let's go in and disconnect this part. Again, kind of neat, highlighting in this release we have autocompile. So as I disconnect it, the rig is already reflecting the change. I don't have to do anything. So you can see how right now these are just placing the bones without changing any of the scale. and then we'll add the squash after, the stretch after. So this is using a node called fit, chain, and curve. And what that does, it takes a 4-point Bézier curve that we procedurally create here. I'll show it in a second. And then positions the chain on that curve. So I can enable it by going into the details panel and enabling the debug. And then you'll actually, if I disable the bones for a second, you can see it really well. You can see the curve as it's drawn. You can also see its tangents. So this guy here has a tangent point down here. And then this is the interpolation that it's putting the chain on. And then once that's done, what I do down here is I take the second spine bone, I measure the distance, and this is a rough estimation. I measure the distance to the pelvis, and then I interpolate that value, giving a minimum of 10 and 30 units, and I run it through this curve to give it a smooth interpolation, and then I change the scale of these bones. So if I just bring this back in, that now gives me this behavior where they will start scaling if they're in that range. And you can use debug, watches and stuff like that to see what it's giving you. So you could go in. This is the way I set this up. So you can say, watch this value, and then watch this value to figure out the ranges. And now as I move it, you can see, right, the minimum that I chose was 10. So at 10, it stops with the maximum scale. And then up here at 30 somewhere, it stops again at the minimum scale for the stretch. And then this curve, you can be adjusted to have slightly different interpolation. So I can adjust the tangents to give it a different feel, and so on. So I wanted to show the curves because they're actually quite interesting. We have a bunch of interpolation nodes for curves, and they can be used for better auto-directability of rigs. And of course, you can blend between them and do a bunch of things with them. All right, so then my last one. So what I want to also mention is this is not necessarily new for this version. We've had it for a while. But in difference to Blueprint, most of our nodes have the ability of being stateful. So what does that mean? Usually when you want to simulate a value, let's say a float growing over time or something like that, you have to set up a variable, and you have to add to that variable over time and do your own math sort of to figure that out. And for a rig, that can be very involved because you might want to do simulations on things everywhere, right? And so what we've decided to do is come up with stateful nodes. So in this example, I have this rig. You've seen it before, actually. It's the exact same one that we used to look at, but we're doing something to the control value as it's coming into the rig, again, just for sort of demonstration purposes. So right now, what I'm doing is I'm basically drawing what that resulting transform looks like somewhere. I think down here, I'm drawing this value so you can see it as an axis. If I don't have it selected, you can see the axis here. And obviously, as we're just piping it through, it's like the same position, right? Now, the next thing I could do is instead of just running this value through, I could go ahead and wire it to the accumulate. Now, the accumulate is one of the simulation nodes. You can find them in the contextual menu on your simulation. There's a bunch of different ones, and we have average and delta and value over time and value integrations. What this does, it basically blends towards a target value over time. So it doesn't copy the value straight. It will stick to the previous value a little bit and then blend against it. And that means as I'm moving this control around, I sort of get this hand to arrive at that location. Right? So for an IK on a hand, that's probably not a good thing to do. But for lots of other things inside of procedural animation, that's really useful. Like good examples are creatures like fishes, where you want the fins to follow with a certain delta over time, certain motion combined with harmonics. That can be really useful. And obviously, you can do this on anything. You can not only do this on vectors, but on floats and other values you're running. You could do a metric, right? How far are the hands apart? And then run that through an accumulate lerp, and then use that to drive procedural animation. So there's a lot of options with that. And we also have other simulation nodes. So the only other one I'm going to show is the Verlet. And that's just a Verlet integration that gives you springy behavior. Right? And you can do that, again, on vectors, transforms, on floats. And it's useful for creating spring alike. This is not a full physics simulation. It's just a little integration that you can use for secondary dynamics, antennae on creatures and all sorts of stuff, right? But it's interesting you have it directly here, and obviously you can have, you could say create a lerp. So we'll just create an interpolate, right? And then we would go ahead and run this guy in here, and now run this and interpolate it with the original control, let's say, just to demonstrate this. And now, right, you have something where you can animate how much the relay is visible, right? So right now it's 100% visible. If we put this to 1, it's turned off. We should probably turn around these ports. But anyway, you can set it up in a way where you can drive exactly, right, what you want to see, features turning on and off, etc. And with that, if there's nothing to add, Jeremiah, I'll hand it back to you.
Yeah, I did want to point out real quick on your squash and stretch example.
Yeah.
Just to backtrack real quick, it does highlight one of the powers of the propagate to children. We've been asked about this before. In what scenario would you use this? Well, in this case, we see the body is doing the scaling, but the arms are still maintaining their scale. So you can control exactly what's changing and what's not.
Yeah, these guys are turned off. That's right. Yeah, I'm scaling the spine bones, but I'm not scaling the arms with it. Yeah, that's true.
Yeah. And additionally, the arms are going along for the ride when you're adjusting the fit to curve, but they're not going along for the ride for the scale. So you're able to finely tune what's happening when it's happening.
Yep, that's very true. So we do have, sort of the parent-child constraints that you know from other 3D packages that you can drive if you want that to happen or not. And they're literally, like, they wouldn't have to exist, but we keep the hierarchy as it is. So based on the child-parent behavior in the tree, they're going to inherit or not, depending on the setting. Which is why you'll see the setting on every single mutating node that mutates the hierarchy. And we've decided, arguably, you could say this is wrong or not, but we've decided to have it turned off on all of them by default. So you always have to turn it on. The idea here is that turning it off means the rig runs faster, and we'd much rather have you consciously turn it on than forgetting about it and then having this extra cost everywhere. Yeah, that's all. I'll close my screen share.
Thanks a bunch for that. All right, we definitely have a couple of questions, if you don't mind tackling them.
Yeah, that's fine. We have a bunch of things to cover after, right? If I recall correctly, Jeremiah. But yeah, let's spend a bit of time in answering questions that came up until now. Sure.
Someone's wondering if it's possible to cache the results of Control Rig. Maybe it's worth mentioning sort of how you go through, how to essentially record this as an animation.
Yeah, you absolutely can. And I was going to go over some of that stuff with our sequencer demo, where you can place your character. You can either run through gameplay, or you can add it in a level sequence and record the results there as an M sequence that you can use in any of your gameplay.
I think if that's the case, let's just go ahead with the presentation and we'll continue with the questions at the end of it.
Okay, yeah.
Sounds good.
All right, so yeah, next I wanted to go over the Mannequin Rig demo. I'm going to go over, again, what we did, why we did it, and how you can adjust it yourself. So this is the Mannequin Control Rig. When you open up the project, you're going to get something that looks kind of like this. We have our mannequin in here, and it's just got some basic animation on it using sequencer. And actually, just to address that question we just had, if I wanted to save this animation and use it during gameplay, I could just right-click on the actor here and create animation sequence. And that'll save an anim sequence and avoid having to go back to FBX. So if you wanted to export to FBX, you could.
It also, just for clarification, also records any of the procedural animation on the bones.
Exactly,
right? So
it records
some base animation on your hand, but you had like something else that's connected with a procedural spring that you built that also gets recorded.
Yeah, and that's a good point. I've used this before on Fortnite, for example, where I wanted some dynamic simulation, some procedural motion that I had created in Control Rig, but I wanted to bake that into an animation. So I created that procedural motion, recorded that motion, and then merged that in with my base animation. It worked really well. So in that way, I was able to use Control Rig as a tool and not just animation platform. So let's take a look at this real quick. We have our mannequin. We have a set of controls, and we have a pretty basic graph. And when I created this, I wanted to be kind of an educational platform. I didn't want to go too complex with it, and that's one of the reasons why it doesn't have fingers and it doesn't have like IKFK on the arms or an IKFK spine. I wanted it to be a way for everyone to step through and build complexity as they go through this graph. So in order to do that, I started just with grabbing each control, and in this case, I'm getting a control in its global space, and I'm passing it into a set transform for a bone. And all the way through, I have propagate to children turned on. You'll see I just start with the root pelvis. I go down the spine. It's all doing the same thing, nothing new here, and the head. As we step down, now I get into an arm. An arm is a clavicle. In this case, it's a clavicle, and it's an IK, a basic IK. And I'm I've created a basic pull vector we've got available back here that I'm feeding into position to. And you saw Helge do a demonstration of exactly how to set that up. And then I have a control that's representing my end effector. And with that, we have animation. So we have both the same thing for the left and the right arm. And it gets a little more complex, again, when we go into the legs. Here I wanted to introduce math nodes just to illustrate that you can do all these calculations yourself, or these calculations can come externally if you wanted to feed in and determine where these pull vectors are, for example. So I wanted to create a little bit of a foot, kind of a reverse foot. So again, I have my foot control, which is just like my hand control. And then I'm doing a little bit of calculation for where my IK effector is. So a few ways that people would do a reverse foot would be a stack of controls, and then you parent the IK under the lowest control. Or you could have constraints across, have a reverse foot and a forward foot, and constrain between those. There's a ton of ways to do it. In this case, I wanted to have each one of these controls affect my IK. And so I have a toe, I have kind of this little effect that I have here. And there's nothing procedural, it's just the parenting structure that I have that allows this. But what it means is that I wanted my IK to be essentially parented under this ball control effects, but I also wanted my IK to be under this foot. So in order to do that, I'm calculating, I have the calculation from my foot control to my ball control and getting the relative offsets and piping that in. You could think of it as kind of like a parent constraint when you maintain offset in Maya. And then we do the same thing again here for the toe pivot. So I'm able to calculate these, and this is an interesting way to see that I'm actually doing some calculations from the bones and controls and piping it in again to a bone. And again, I'm just duplicating logic for left and right.
One of the things I'd like to mention real quick here is that some of this is constant. So I want to bring this up in terms of performance real quick. So get initial transform and get control initial transform, this little branch of these three nodes that say get initial, and then make relative, this whole thing, these three nodes, they're all constant, right? So they don't change at runtime because the initial transforms never change. And so the compiler, when we optimize the rig, actually computes this once and keeps the value, and these nodes are not run at runtime. I just wanted to highlight this because a lot of times people think like, what, can I add all these nodes? Is it going to cost us anything? And anything which is constant gets folded. We call it folded. So we remove the nodes to keep the result. We keep the nodes here, obviously, for the user, so you can see what you're doing. But a lot of the rig that you're showing isn't actually run. It's just there to describe, right, what is the overall relationship of everything. But then during runtime, we optimize it as much as we can.
Yeah, that's a good point. And yeah, I've seen online a lot of people are focused on this execution stack and kind of using the number as a gauge for performance. But with Control Rig, it's designed to be hyper performance and does a lot of optimizations for you, like the internal caching if the values are going to be static. So far, I recommend using it as kind of go crazy. If you run into performance issues, I'd love to hear about them and hear about those cases, because it is really designed to be optimal and just really quick, just for procedural motion and for authoring animation.
Yeah, the way I usually go about it is very similar to coding, is don't try to outsmart the compiler by trying anything which seems smarter. Or in fact, go for readability, go for what you feel like makes it the best usable asset. And if you come across performance issues, like Jeremiah said, we'd love to hear about the performance issues, because that makes it our problem. We can't go for like a system where you have to trick it to make it fast, and then have it like you pass on the rig and the other person can't use it, right? We go for simplicity over performance, and we'll try to solve that for you.
Gonna take this opportunity to let everyone know that if you are interested in continuing the conversation, or if you're working with Control Rig, the forum announcement post for the stream is a good place for those discussions. I'll go ahead and drop the link.
Let's see. Next, I want to talk about. What do I want to talk about next? right, so I went over the rig real quick. I don't know if there are any questions about this rig outside of what I've mentioned, but I do want to talk about how we can augment this, adjust it, how a user can make this their own. So a common question is, why didn't you add fingers? That's fair. It's because it's at the end of the day, there's a lot of different ways to do it. And I didn't want to just duplicate the same logic that we already learned at the beginning. And so this kind of keeps it a way to learn varying ranges of complexity. But in order to add fingers, you could duplicate this logic for just straight FK controls down the fingers. Or you could use the distribute rotation that we learned earlier where I showed from the spine to the head just based off of vector 2D. Or you could even use the CCD IK or the fabric IK that Helge showed to do some sort of IK control. And you can blend all of those together. An example that we could do on the arm, if we wanted to do IK FK arms, for example, would be we could create a new float control and drive the weight value. Then you can blend on and off your IK, and you just have IK controls and FK controls. Again, very similar to the type of logic that we do down here at the leg. So from these building blocks that we put in this mannequin rig, you can extrapolate a lot of different ways to design the rig to do exactly what you want and the way that your animators would like to interact with it.
I'll also take the opportunity to mention, stay on the live stream, and eventually we're going to talk about a bit of an outlook for 426, and we'll probably mention fingers again then. That's all I'm going to say for now.
And a little sneak peek. Yeah, all right, so let's go ahead and I think I have just one slide just so we can officially be on the next step, which is sequencer. So once you have a rig, we want to animate the rig. What good is a rig if you can't animate it? I mean, as a rigger, you feel really good about yourself. You made something pretty cool, but we want to create that cool content. So I'm going to jump into the next step of this sequencer. As I mentioned, when you download the sample project, we already have a level sequence in there for you and a quick map. You can see this animation playing. And again, you can right-click on this, create an animation sequence, and use that for your gameplay. Let me get to my notes again. So a few things to mention. I want to actually show several ways to use sequencer to animate your rigs. We're going to start basic. I'm just going to create a new scene. And I'm going to drag in my mannequin here. And a way that people are used to interacting with the level sequence and adding an animation is you have your actor and you just add in an animation. So I'm just going to add in, let's say, the walk. And we'll play this. All right, so I have a walk animation. Let's say this is mocap, for example, and the fingers aren't animated. Well, a quick way to do that is to use a new track available to you called Additive Control Rig. This is an auto-generated control rig that allows you to manipulate bones additively on top of your animation sequence. So I'm just going to go ahead and add that here. And you see it created a track, and it's got all of the bones available for you to keep. Let's go ahead and keep playing this. Just to, I'm going to do this a couple times just so I can illustrate what we can do. I'm going to set some keys and rotate that up. And all right, there we go. So I do have auto key turned on, which is allowing me to just get that interpolation immediately. So you can see that I've got some horrible additive animation on top of this walk sequence. If I wanted to take my mocap again and tweak it real quick, let's say adjust the finger pose, and then save that out again, right-click, create animation sequence. Or if you're a tech animator or rigger and you want to create some quick poses for a pose asset, you could do the same thing here. You can right-click and say create pose asset. So this is using the additive control rig. And it can be a little cumbersome when you have all of these controls showing up. There is a way to work around that. You can just right-click here in the section on your Additive Control Rig, and you can toggle rig controls. So here I'm just going to turn off all of them, and then I'm going to turn back on the ones that I want. Shortly, I'm sure. So what I'm going to do...
Quick question, Jeremiah. And this is putting you a bit on the spot, but don't you have a degree in animation? I mean, this edit is a bit simplistic, if you ask me. I mean, he's looking like he's enjoying some music. That's what I think. Yes. But yeah.
Yeah, I say I technically have a degree in animation, which is why I'm a technical animator.
Nice. All right.
So now I can turn on my upper arms. Where's my left one? There we go. All right, so now let's say I just want my upper arms, or if I just want my fingers, I can add those in, so that those are the only channels that I see here in my Additive Control Rig. So that's one way to animate with Control Rig. But let's look at another. I'm going to go ahead and delete these, and now I have just my skeleton mesh. You can also, I'm just going to click on track again instead of adding an animation or my Additive Control Rig. I'm going to choose one of the control rigs that we've created, and in this case, it's going to be the Mannequin Control Rig. Now I'm able to animate this directly as if I were just animating in a DCC. And I'm going to take a quick moment to pause here and point out a few kind of tips and tricks for animating in sequence. So the first one I want to mention is this animation mode, which should automatically pop up when you drag this in. Has a couple cool features. One is only select rig control. So now as I'm clicking through here, I'm not clicking through and getting I have that selected from previously. I'm not getting my skybox or my backgrounds. I'm only able to select controls. This makes it a lot easier for interacting with your rigs when you're animating in your levels. Another one is I have a control hierarchy. So I can leave my search up here. Let's say I only want upper arms. If I could spell. Let's see. Upper. All right, I can't spell. So additionally, this is live controls. As I'm selecting this, it's also selecting my control, my viewport, and it's also selecting the control here in sequencer. And if you want your sequencer to be a little simpler to read, you can adjust this filter and say selected control rig. Maxing out my system here. All right, so now as I click through this, maybe I lied. It's not working for me right now. Ignore that.
It's making it faster for sure.
It definitely made it way faster. Yeah, now you don't see the controls. Yeah. So that part doesn't seem to be working, but it is really helpful to have this control hierarchy up when you're working, so you know you don't have the flat list. And you can also use the filters, the search through the tracks, through here, and setting on auto key so you can quickly key your tracks that you're going through.
I think I got it now. I think it's because everything's called forearm and not upper arm in this rig, so that's why upper wasn't finding anything.
Oh, because they're the controls, and I have the bone names in my head. That's what's
Isn't happening. That right? I think that's why I was like really confused because the search is working. It's just I think it's forearm.
There you go. Yeah, I just
not upper arm. So
I've been in skeleton land for so long.
Yeah, that's fine. Get it.
Yeah, so those are two ways to interact with your rig, both dragging in a skeletal mesh and animation, or it could be an actor and you throw an animation on there and use your Additive Control Rig, or have a skeletal mesh or an actor and adding in a control rig as a track. One more thing that you can do is to really quickly set this up. Sometimes it's tedious to go through, add a level sequence, and plug everything in. Is I can just drag and drop a control rig into my level and it'll set it up for me. So here I'm just going to drag my control rig. Control rig pops up. It automatically created a level sequence for me and added that mannequin control rig in as a track for me to start animating immediately. All right. Let's see if there's any last things. Yeah, I think that's what I wanted to cover for this.
That's great. I mean, just to clarify, setting up the sequence like this is the same as doing it manually. So, of course, it's faster, right? But the point is, if you want to customize this, add tracks to it, it's just a level sequence. It's the same setup. It's just sort of a little script that makes things faster. As you drag a control rig in, it picks the right skeletal mesh, creates a level sequence, puts the actor in, puts the track in, and sets everything up for you, right?
Yeah, exactly. A couple of more quick things to note, actually, when you're animating in here. Especially when you're creating controls with limits, like a vector 2D control. Make sure that your snapping is turned off. I've run into this issue if my snapping is set to 10 because I've been doing some set dressing or something. And then I'm trying to move a float or vector that's limited between -1 and 1. It's not going to move, and you'll think that it's broken, but really it's just your snapping is turned on, and so the control's not able to leave that 0 to 1 space. Again, the select only controls is really helpful, or only select rig controls, which is available in the animation details here. You can turn on your hierarchy if you want to see your skeleton and see what that's doing. Maybe you have some procedural bones and you want to see if they're moving. Additionally, as you have controls selected here, you have your transform available. So that allows you to set values directly as a transform and also key them here. And one more thing I meant to mention as we were going through the mannequin, but I have some nested controls here, and there's a little bit of confusion about why I did that. That's just coming from rigging, or coming from animation. You want to be able to have some additive control. So maybe my gross movements is on my pelvis, but then I still want to tweak my, or on my body, and I want to tweak the pelvis a little bit just for offsets. Sometimes you'll layer controls just to give animators ability to highly refine the way that they're interacting with the rig. Another great example is you have a gross movements, gross general movement, and then you want to have just fine jitters on a control. You want that gross movement to be on one control, and that fine jitter not be muddying up your curves for the general movement. So that's why we added some of those in.
So also, as we're going to look at runtime rigging next, I just want to highlight that if you're not planning on using the rig for runtime rigging, but for authoring animations like this, for creating animation assets, you can go nuts with the complexity here, right? Because when it's baked down to an animation asset, there's no performance cost to any of these controls. So in other words, adding more granular control and getting real high fidelity on authoring and making it really easy for animators to get just the exact animation out of the character that you want doesn't cost you anything in terms of performance when you bake it down to an animation asset. So that way, like, go nuts. So there's no cost in having multiple layer controls like Jeremiah was showing.
Right. Yep. So that I definitely recommend just have fun and add in procedural motion, add in authored controls. You can do some really cool things when you start combining the types of nodes that we have available in Control Rig. Something else you'll see in Control Rig is we tend to build it as a framework. So it's from the ground up. So you'll see very small math nodes. We call them just kind of atomic nodes. In fact, in Control Rig, we call them rig unit. So each rig unit is originally designed to be these small little bits of logic that you can build into more complex logic. And as we continue building Control Rig, we'll see higher level nodes that are essentially going to be versions of a bunch of smaller nodes combined together. So you should have the ability to create really complex behavior, and eventually we'll see the ability to have just, IK, FK switch with my arm and all the controls that I need for that, as an example. All right, so now I want to hop on over to the runtime rigging. And again, we've mentioned this before, and really this is the ability to have a procedural rig that's doing some sort of behavior on top of your animation. Or it could be a control rig that's doing all the motion for you based off some sort of gameplay. Let's take a look at this real quick. I want to show you first what we're going to be looking at, and then we'll take it apart and see how we did it. All right, this is my trusty mannequin, and we've done some slight modifications. So he's got a hat on his head with a propeller, and as we run around, based off the velocity, he's the propeller spins. And I'm also using some interpolation, so once I stop running, the propeller slows down to a stop. I'm using the entire velocity of the character, so not just using 2D, and that gives us some fun results. Additionally, I've added on just a little piston onto his arm, so we can see it aligning based off the arm movement. So this is illustrating taking gameplay logic and feeding it into Control Rig, and taking existing bone transforms and manipulating something procedurally. So we did this.
Can I just say, I really love this content. I think it's awesome. It's so simple, but it's so fun. I like it.
Thank you. All right, so let's look at this. First, let me show you my anim graph. It's pretty straightforward. Everything we've shown before has been Control Rig kind of as an asset and dropped into a level and manipulated. But now we're looking at Control Rig as an anim node and an anim blueprint. And all I'm doing here is I'm using this anim blueprints as a post-process graph on my skeletal mesh. So we can see I got my skeletal mesh up here, and I've just plugged in my example content here. We also see something interesting. We see I've added the speed variable that I've calculated in my event graph. I'm just grabbing the pawn and getting its velocity. And I'm plugging that into my Control Rig. And this is illustrating parameters. So this is a way that you can get external gameplay logic, however you want to calculate that. Maybe your anim instances have some logic that it can pass through, or you can calculate it here locally. And I'm using that as an input into my Control Rig. And let's see how we set that up. All right, here's my Control Rig. We're just going to focus on this part, which is the propeller spinning. In order to create a new parameter, let's go ahead and create one now. You see new parameter and you see new variable. There is a difference, and in 4.2.5 we see parameters as taking external data into the Control Rig, whereas variables are managing internal data, just storing a value and using it somewhere else within that Control Rig. And that's illustrated through variables have getters and setters, whereas parameters only have getters. So if I wanted to create a new float, I can just click in here and type in something, say my cool parameter. And now I have a new parameter called my cool parameter. I already have one created called propeller spin. And if I click on this, you'll see that's the only one I got available. So my setup is take in the value. In this case, its speed is getting passed from my anim blueprints, and run it across this curve. I'm using a curve instead of a remap or instead of a multiplier, so that I can refine the way that the speed of the propeller ramps up. So if I want to wait until I'm fully sprinting, so I want the propeller like slowly speed up, and when I'm fully sprinting, then it's really going, I could adjust this curve to be something sort of like this. I'm doing the remapping, so I know my speed just from watching my anim blueprints during debug, that it's going between 0 and 600. So I'm remapping 0 to 600 to a max rotation speed. In this case, 40 seemed about right. I'm using our accumulation nodes, and we saw a few of those previously in our examples. In this case, I'm just doing accumulate add. So I'm slowly adding the value, and I'm starting at 0. And then I'm just converting that to a rotate. So here I'm just spinning on X and setting the rotation in local space. I don't need to be in local space. I just need to spin around. So let's test this in here. Let's create a quick example of how to test it. I'm going to use my favorite example. I've seen it a few times already, where I'm going to create a sign, and I'm going to use time. I'm going to need something that goes a bit more extreme. So once again, we're going to right-click and add an interpolate node. I really love these things. My in range is -1, so it's a sign. My out range, we'll call it, let's leave it 0 to 1, so we'll clamp it. And we'll say 0 to 600. There we go. So now we see as time is fluctuating, or as the sign is fluctuating, it spins up. And I'm using the properties of the map to ignore anything below -1. So that allows us to see it settle once sine is down below 1. And this allows me to kind of fine-tune what that speed may look like. So here I may go real fast, real quick. I don't want a slow ramp up. So I have some art direction available here. Let's go ahead and go back to my parameter so that I keep my incoming data. And now let's go over and take a look at this, this piston that I've set up here. Here I have just a couple aims. And I did change a couple values in here to make it work better for me. In this case, I have my upper arm piston, which is this bone, and it looks at the lower arm. I have these bones just parented under upper arm and lower arm. And I've set these values to work for each bone. So in this case, since both of these bones are pointing down the arm, I want this bone, the lower piston bone, to be looking back, in which case I'm using -1 on my axis to get that behavior that I want. I'm using location because I'm using the targets of the opposite bone as my location. I think I may have adjusted my... no, I think I left my secondary axis the same. Since in this case these are round, it doesn't really matter if they spin along their axis, so I just left that alone. And that's all I have here for this logic. I could make this more complex. I could say once I've reached a certain extent, then scale these pistons, or I could so I get some sort of stretch or some compensation so I never get a gap. But I left it simple for now.
There's something I'd like to just up for here, Jeremiah, which is that it's hard to understand initially, especially coming from an environment like Maya, where the execution is bound to the DG, the dependency graph, right? Where you can't introduce cycles in a dependency graph. I mean, you can, but it's not recommended, right? Whereas for us, you can have, like, this is a good example. Like, you have one bone looking at the other one, but then you have like bone A looking at bone B, but then you can also have bone B looking at bone A. It's not actually a cycle. And that's because our graph only describes what needs to happen in order. And there's no problem if you for example, aim something once and aim it again later. It's not a problem. Or you can decide to not aim it again later and have it procedurally turn on or off or whatever it is. And that's because we're actually creating a stack of execution. We don't have a graph at runtime. We have a list of things to do. And that gives you much more freedom than you would have in a DG-based execution environment.
Yeah, absolutely. And you saw some of those as another example with the way that Helge was controlling the IK with the Verlet. And you can add those effects on top of the control to move the control in space and then animate on top of that control. You get this cool, complex behavior that just wouldn't be possible otherwise. Let's see. So one thing I didn't mention here in the anim graph is, how do I get this pin on the control rig? Once you've created a parameter, in fact, let's go ahead and create a parameter again. Let's call it, no, let's just make a bool. I'm going to say my bool. And if I go, does this show up automatically? It does. So once I click on the control rig, it automatically shows up. I can pass in a pin or I can pass in a curve. So if you have some really complex logic, or logic, it doesn't matter, as curves that you're passing through, you could map those through your anim blueprints to drive your control rig. In this case, I'm just setting my value based off of gameplay logic. And in order to have that pin show up, I'm just going to check this use pin, and the pin shows up on my control rig, and now I can use it however I like.
A way to rephrase this, which I quite like sometimes when people are really experienced with the anim graph, is that runtime rigging really means you have the ability of building your own anim nodes, right? That's basically what this is. You now have a control rig node, which is running another piece of logic, where you have more freedom and more flexibility, simulation capabilities, lots of things that you don't have in the anim graph. So you can use it for building your own nodes, basically, right?
Yeah. And another thing to mention is, runtime rigging allows you to create complex behavior on top of existing animation without relying on baking animation or having all that logic existing in your DCC rig. So in this case, let's just show really quick. I have my trusty mannequin here. Let's do, I want actually my base mannequin. Here we go. So I'm using this mannequin because he doesn't have the propeller and the. Actually, I'm doing this all wrong. I want to use my runtime guy. Here we go. All right. So I have this guy because he does have this the additional contents on there. I'm going to go ahead and add a level sequence, and I'm going to let's go ahead and add this dude. And I'm going to add an animation. In this case, it's just animation that's available from the third-person sample content. So let's do walk, for example. And come on. So as I play this, you can see the piston is working automatically. Even though there's no animation available in this walk cycle, I'm still able to solve using post-process graphs. So what this means for your characters and in your games is you can have a base locomotion set for all your characters, and you can do all of your secondary complex, let's say shoulder pads, loincloths, pistons, anything you can think of that would just be procedural dynamic motion. Don't bake those into your anim sequence. You can build a control rig and do that logic for you. And then all that secondary logic is reactive to your game as you add in more content. Say I add in a new emote for this, the piston will work for it. I don't need to update all of that in my animation. I feel like I have one more thing. I think that's good. All right, I think we're ready to go on to the next thing, unless we have any questions about runtime rigging.
Maybe you want to pause. Is the next thing the lookout? What is next?
The next thing is looking forward into 4Q.
So I'd say let's do a series of questions if we have any before we go there.
Yep.
We have plenty of questions. Some of them I believe you have addressed. There were definitely a couple around the topic of runtime rigging, and I think we tackled that fairly well. If there are any more questions there, let us know. Something that I wanted to point out, sort of the runtime rigging. For example, that's the stuff that you can do for, say, a full body IK rig for a VR avatar, right? And you would essentially construct your own control rig and then use those nodes inside the animation blueprint to be able to drive that rig. Is that correct?
Yeah, that's correct. So, for example, with this guy, if I wanted to, instead of driving, in fact, I could even do it. I could create a parameter that would be a transform parameter. And in this case, I'm taking transform inputs, and I could feed it wherever I want. So in this case, let's go ahead, and this is a great way to show how I can combine logic on top of controls, still drive controls, and have animated full controls. So I'm going to have this transform parameter. It just has a default name right now, and feed into transform. Here I'm going to drive the control location. I'm not going to do a full setup of this, but hopefully we can illustrate what we're doing. So I have my left hand here. I would set my my control transform, and then here. So I could drive my control transform through an external parameter using the control rig and blueprint that we showed here, and that transform would just show up right on my control rig node, and I could feed in transforms through my gameplay logic. If it's a VR inputs that you're handling through blueprint, you could pass that through an anim instance, or any other gameplay logic if you want to do that dynamic.
There's also you could add parameters that building a rig that by default has controls. It also has transforms, but they're sort of ignored. The weight would be set to 0 in this case. And then you can have a parameter which is sort of your turn on for runtime parameter, right? And then what it would do, it would set up all these weights, so to overdrive the controls with runtime values. So that way you don't have to have 2 rigs. You can just integrate it with one. And again, for some optimizations we do, if you have branches which are constant, in other words, there's a branch that is never going to be active because you have a weight that's always to 0, we're optimizing that out anyway. So don't worry about building more logic into a single rig. If you're not going to use it, it's not a cost.
And you could even then use the same control rig to capture those transforms, recording those transforms using sequencer, and sort of act, right, if still on the topic of the VR avatar, and record those transforms and then play them back at runtime to have a sequence in runtime playing in the editor where you see someone who looks like it could be what the player would look like, and act that out.
It's absolutely like one of the things we found, and this is maybe getting me super nerdy, but your
That's
question
what we're here for.
does make me nerdy, which is that you can use Control Rig as classic replacement for linear content creation for authoring animation, right? But you can also use it for runtime rigging. But you can also use it, and that's where it gets really interesting, as part of your tooling. You just use it, like Jeremiah was mentioning earlier, you use it as a middle step somewhere in your custom workflow where you use it to create some procedural animation mixed with something else. Maybe you just use it to bake the upper body because that's what you need for your particular scenario in VR, and then you combine that with other keyframe animation from another source. It's really there for you to experiment, part of our Lego bricks, really.
So one of the questions that came up in regards to runtime rigging was if we have done any tests on sort of the performance cost. Do you have a ballpark that I think that's sort of what we're looking for, not exact numbers, but say, I think the question was, what is the performance cost of running a full body control rig over an animation instance in gameplay with default specifications as an example?
So we've shared this before, which is why I'm comfortable sharing it again. We use Control Rig on a majority of our characters on Fortnite, and we've seen some characters in previous early seasons, for example, with Werewolf and the big mech. Those are running full Control Rig and being driven by retargeted animation. So we have Control Rig, we have animation, we have layers of, your backpack is attached, and the backpack may have dynamic motion that's also using Control Rig. And then you multiply that by the scale or the number of characters that you may have on screen. And we're running that on a Switch, or running that on a phone or a PC. So it's designed to be performant, and it's designed to be flexible.
I mean, that being said, there's a grain of salt. I mean, as it's a big visual system, you can build a rig which is not performant, right? You as a user, you can build one that is just so big and does so many things that it's not going to fit your requirements, which is why we've integrated a profiler into it. So you can look at all the numbers, you can see how long things take, you can see which nodes are taking the time. And we use these tools, like Jeremiah said, to run it on the majority of the characters that you have in a current Fortnite session. So those rigs, to be fair, are usually not full body rigs, but their sheer number sort of, I guess, compares, right? So if you have 100 players with partial rigs, let's say half body rigs, if you will, then that gives you an idea of the invocation cost. If you have like 3 characters.
Yeah.
All right, let's move on. Let's see how many of these we can grab. Can you pause a running game and adjust the pose with the control rig?
Okay.
I'd wish you could. I don't think you can right now. Yeah. You can attach control rigs like blueprints to runtime instances, so you can look at the value in the pose going through control rig for a running game, but you can't adjust it. And I don't think you can pull out the values. You might be able to copy and paste off values right off that instance when it's paused, but yeah, you can't adjust an animation in the gameplay. That being said, control rig has been designed to eventually do this. I'm not going to say when we do it, if we do it. It's more, it has been designed with a clear separation that all the things necessary to do adjustments to a rig at runtime are there. It's just workflows around that are not exposed.
And just talking about debugging, I thought I'd bring up just a real quick example here. I'm running around. I have control rig, or actually I have my hand. Let's debug this guy. All right. I don't want to fuss with this too much, but you can live debug your control rig and tweak your parameters. It's not adjusting controls, but it's adjusting your graph and having it line come out. I think we actually had a couple questions that we wanted to answer that we'd seen.
Yeah, you can go ahead and tackle those first, and then in case some of them are covered, I'll just move on with the other questions.
Yeah. Helge jumped in and he talked about spaces versus controls and different ways that you can drive logic. One thing that came up was how can a bone be used? How can you add bones, or when you add bones into your skeleton, what can you do with those? In 425, you can use those to calculate kind of intermediate values. You can use those. You can use, for example, your IK solvers and solve those on those intermediate bones, and then derive some sort of logic from those. It also allows you to start doing kind of simulation or and feed those values back out to an anim graph or different areas of your rig. You can solve things in different ways parallel. Helge,
basically in technical speak, if you add a bone, maybe you want to do that here in this rig just so we know what we're talking about.
Yeah.
If you add one of these green bones, they show up in a different color if you add them to your hierarchy. And we're talking about adding it to the hierarchy. So,
yep.
What's happening, man? All right.
What have I done? So, all right,
just add a single bone somewhere. That's what I mean.
If I go here and right click, I can say
we don't actually have to use it for anything. Just add it there so we can see it. So there's a new bone being added to the hierarchy. It's green. You can rename it. You can put it anywhere, and they're just parented in. And so basically, what these are, right? They're not real bones. They're not part of the skeleton, but they have the same characteristics as in they have parent-child relationships. So if you give them a local transform, you can ask for the global transform as facility, and that makes it easier. But really, what they are, they're transform variables, right? They're just variables you can use for simulation with a parent-child relationship. So lots of times you want to put something like a jiggle under the clavicle or something, and you want an easy way to ask for where that is globally. You could do that with a variable transform variable and compute the global all the time yourself, or you can just put a bone there, simulate it, and then in some later form section of the rig ask for the global of that, and it's an easy accessor. Right? That's the reason why we make it part of the hierarchy. But that's really what that is. They're not real bones. They're just transform variables with parent-child relationship. I hope that answers it.
Another question was about control rig sequence. Now, this was something I think in 424 and before. And that was in Sequencer, you were able to create a control rig sequence or level sequence. And level sequences, now everything gets added into a level sequence, and you're able to bake out that animation as an anim sequence if you like. So we don't have that difference. I think it's been deprecated. We're going through some more questions here.
Yeah, I can grab one from chat in between, if you don't mind.
Yeah, go for it.
Could positioning and rotation of rig elements in a scene be accessed via Python during runtime of the game?
No. Python, well, maybe yes, but I'm going to say no. Python, I don't know if it could be done. I wouldn't.
No. I'll ring fence this topic. No, it's because it's very simple. We use Python as an orchestration language, is what we call it. So for tooling inside of the editor. So that's what it's there for. So yes, you can adjust the pose of control with Python in the editor. In the runtime, you have access to C++ and Blueprint, right? That's what you have. And both of those, you can access controls and set them. So you can use Blueprint as well for that. It's just you don't have access to Python in the runtime, which is why you can't use Python for controls in runtime either.
Yeah, so in the case that I would use Python is generating controls, generating your node graph in control rig. So this is constructing your control rig, not driving your control rig in the editor.
If you're curious about our Python integration, you can go check out a stream we did last year with Aaron Carla. It's in the playlist. Did you want to move on with your question? The next one's Jeremiah?
Sure, yeah, we had a couple questions around physics. Both physics and driving control rig with physics, or attaching objects to something that's dynamic like cloth. So currently, you're not able to feed in a point on a cloth mesh into control rig unless you have some way of deriving that logic through blueprints, in which case you'd pass that value through a parameter. But that's not directly supported. That would have to be logic you'd have to build out. And driving control rig with simulation is not something that's directly supported, but you would be able to, in serial, have a rigid body node and then your control rig node, in which case, since the control rig node would be taking the outgoing pose from your rigid body, it would act relative. So you have the ability to determine where your control rig is solving.
All right, should I continue?
Go for it.
How much time do you guys have?
About
Still good to go? All right, let's continue.
Good go.
Sure. There's still questions, so let's try to cover some of them.
Yes, there are. How can we use multiple control rigs based on the same skeletal mesh in the sequencer? Is it possible to create interaction between two characters using this?
We'll pause that question for now.
Pause that question for now? We're going to pause that question for now. In 2-bone IK node, what is the difference in result between the two options under pole vector kind?
It's a great question, and that's really confusing for a lot of people.
It's a great question. I love that that's coming up. It's been confusing everyone, and I apologize.
Yes.
Basically,
So,
that's my answer is I apologize.
To just kind of let everyone know what we're talking about, on a basic IK, there's pull vector kinds, and there's direction and location. You also have a pull vector space, where you can define a bone. So pull vector location is there is an object in space, and you're looking at that object. Pull vector direction is the direction around a bone based off the specified space. So if it's none, I think it's just that bone specifically. But if you define a different space, you could rotate, say, around the chest. Did I answer that well enough, Helge?
So, no. So, but this is where he shows you that this is sort of a bad option. So basically, location means the vector that is connected to your pole vector pin is a location. It's represented as a position in space. So in this case, it's the global space position of the left knee, whatever control you have there, right? And we're aiming at a position. But sometimes what you're feeding in is not a position, it's a direction in space. It says like that way. It's not exactly the position where you're going, but it's that way. And then this is understood to be a vector and not a position. Now, I added this when we designed this because a lot of my cases where I was using directions to orient something like upwards or sideways. But apparently, this is my learning from this, is riggers think in locations, and everybody wants this to be set to location. And the default, I believe, in 425 is direction, which confuses everyone. Now, I can't talk about too much about the next release, but I can tell you that we've changed the default to location in the next release because this was a major complaint that everybody had. So I hope that clarifies a little bit.
Yeah, I think so. Next one up. Do you include a 3-bone digigrade solver?
No.
I have no idea what that is, so
yeah,
I'm glad
we did illustrate a few of the IK solvers, or Helge demonstrated a few of those available. So play with those.
Yeah, we don't have a specific 3-bone solver. You can do it different ways. Like, I mean, there's different approaches. When I helped rig the mech, we actually used 3 basic IK stacked on top of each other because you can, in Control Rig, remember, you can actually do things multiple times. And we also have, can you right-click? Let's see. I'm a bit on a jump here, so I don't know if that exists in this release. But if you right-click and say basic IK, yeah, so we do have it. So there's the basic IK transforms. Can you use the last node there? So this node is the same math as the basic IK, but it's not actually modifying a skeleton. So you can use it to give it some data to say, like, this is where my root is. And it gives you back the transforms that would need to be set. And what this means is you can actually do multiple IKs, mix them, and create results, art-directed results for 3 bones, for example. Is a good approach. Like, just to say, create an artificial, like, a fiction chain from the root of your 3 bone to all the way to the effector, solve that in some form, and then do 2 additional IK solves for the segments to solve a leg like that, for example. Or, like Jeremiah said, use Fabric or CCD IK.
Or Spring IK, which is our 3rd one.
Yeah, there's another one, I think. Just try them, yeah.
Are there plans for it to be possible to have a single control rig which works on several different skeletons?
It's a bit of a hint, but we pause that as well.
We will pause that as well. Could you control the keyframe/tangents on the curve node with other controller?
No. You mean the which curve node are we referring to here?
Talk about the evaluate curve.
I believe so. Yeah, the one Helge had in his demonstration.
Yeah, so he just had an evaluate curve, and I think he pulled off and created a curve this way.
Yeah, we can't drive other than through the UI or Python. You can't drive the contents of this curve right now procedurally. So you can't create the curve itself procedurally. But if you want to take note, Jeremiah, that's totally something we could do eventually. there's another curve, and maybe just in case that was the question, the Bezier curve that you create to fit the chain, you can totally drive that procedurally 100%. It is always a fixed 4-point, so there's a node that's called 4-point Bezier, and you can create it, set each point, so the start endpoint, the 2 tangent values, and then drive those with controls or drive them differently.
Yeah, and that's actually kind of exactly what Helge is doing here. He's driving those points through controls and then calculating the secondary control points.
Yeah,
but that could be an external parameter or something else.
Yep.
Let's see. Can you expose a property like strength/weight on a node to sequencer along with the controls?
So yes, the way you do it, we haven't shown this yet, but the way you do it is you change the type of the control. So you can create a control. Maybe Jeremiah, if you want to show this in this one, it doesn't actually matter.
Yep. Yeah, I'll do that for sampling precision. So I'm just dragging off a sampling precision, and I'm going to create a parameter.
Yeah, don't create. Sorry to intercept. Don't create a parameter. Actually, create a control.
You want a control,
otherwise, it's not going to show. Yeah. So go into the rig hierarchy, create a new control just at the root for demonstration purposes, and then change its type from transform to float. And that changes a bunch of things. You can see it changes the input fields in the details panel, it changes limits, and it will also change the way that the limits and the control is drawn in 3D. Because now it's basically a slider, right? Yeah. And then you can use this to set a value, and you can animate this. That's basically the answer. You can disable the gizmo. So in the details panel, you have settings around the gizmo, which is a 3D representation of the control. And then that way it doesn't show up in 3D, but it's animatable in sequencer, and you have a float input.
Yeah. Additionally, and it's worth mentioning that there's different ways to adjust your limits, and something I hadn't mentioned earlier, but I like to think of controls as essentially a UI, an interface to your rig, not necessarily transforms that you're manipulating.
Yep.
And so that lets you kind of think of rigging a little differently. So in this case, I could move this flow control just so it's sitting somewhere in space and scale it up by adjusting my gizmo transforms, or I could create a space above this and scale that up and non-uniform scale it, because it doesn't really matter at the end of the day because you're just adjusting this float value. There's a different visual representation of the output value. The output value is not linked. Whereas something like Maya, where you have a transform, manipulating that transform in space has direct ramifications.
Basically, we go in the opposite direction. The way I always explain it, I think that the metaphor to the UI is great. But the way I look at it is, in Maya, you take 3D transforms and you sort of shoehorn them into be a slider by limiting other components, removing rotation from it, all the stuff. We do the opposite. We basically say we have a float, which is just a single number, and we put it in space somewhere. But it only has that single float. So the only thing you can animate is that single float, and you're never going to get in a situation where you animate the wrong component on a transform, anything like that.
Right. So I'm just going to drag this into sequencer to demonstrate. So now I have a couple transform controls, and at the bottom here, I have new control, which is just a float, like we would expect.
Great.
About complexity, do you plan to add something like functions or macros to Control Rig?
It's a good question. That's all I can say about that right now.
I think you tackled this briefly, but dynamic squash and stretch was demonstrated earlier. Do physics bodies automatically respond to those animated changes?
It depends on where you run the control rig, right?
Yeah, so that's a good question. I could see you running into issues because depending on how you're adjusting those bones, if you have rigid bodies happening afterwards and you're scaling those bones non-uniformly, you may end up with some results you're not expecting, including trying to push collision bodies into each other and getting some sort of explosion as they're trying to push each other away.
Is it possible to have something like Maya's set-driven key, for example, where you have an animation curve driven by a slider value?
So if you're talking about building poses and feeding those in, currently we don't have poses implemented in Control Rig. where you can like store those poses, then drive them based off a curve. But one way you might be able to do this is using Control Rig to drive logic and feeding out curves. So in this way, I could say set curve value, and as long as those curves exist on your skeleton, I could drive this value through some sort of gameplay logic. And in my anim graph, I could use my pose driver. And let's go to just add a target, for example. And I can have that pose, which my pose asset that I showed earlier, where I can create poses in Sequencer. I can save some poses, use that as a pose asset, load that in here, and drive that via curve, either demonstrated here or names if I had named curves on the skeleton. And those curves are linked between Control Rig and my pose driver. I would need my Control Rig to come before my pose driver, so it can drive those curves before it.
I mean, there's also one of the testers has done that using the green bones. If you recall, we have the green bones you can add. So if this is about poses on multiple bones, then what Jeremiah is suggesting is a better approach. But if this is about, I don't know, I have a pose in the clavicle, and I will have like 4 different locations this needs to go in, and you want to interpolate using a float, then you could do that. You basically feed in the float, you store the expected different clavicle transforms that you want as green bones, you just put them there as well, and these are the poses you're going to refer to, and then the Control Rig will blend between those using procedural logic. What we don't have is this, one click solution where you just say, like, store these poses and then interpolate between them. The workflow that sits on top of the evaluation in Maya, we don't have that.
Can we create new or assign existing control rig to skeletal meshes at runtime?
You have the ability to change out drive what control rig is active in your anim blueprints. So that's a quick way that you could have logic to determine what you could create branches in here to say, based off this branch, I'm using this control rig A versus control rig B. So that's one way you could do it. I'm sure there are many other ways.
There is another way. I don't know if this is accessible in Blueprint. I'd have to check. But the approach we're taking for Sequencer, we have added a new custom instance you can add to skeletal meshes, and we're actually doing that sort of at runtime in the editor as well. You could do it in runtime in your game. So if you wanted to assign that animation instance to your skeletal mesh, that has all the facilities you need to set the control rig and interact with it. That's basically what Sequencer is using under the hood as well. And it's there as part of Fort 425. So you can, it's not, sadly there isn't a big page of documentation how to do that. But if you look at those animation instances, there's only one in the Control Rig's plugin source code. That's the one we're using, and it's a new anim instance that for this purpose. What it doesn't allow you to do is mix with other anim graphs because it's a custom anim instance. But depends on your case. If you just want, at runtime, have a Control Rig take over a skeletal mesh, you could do it with that.
We had a few questions coming in if it's possible to use animation insights to debug Control Rig.
Not currently. There are some profiling tools available in Control Rig, but with animation insights, made it into 425 and focused first on the gameplay side, and I think we'll see animation insights rolling out into the other systems as we go forward.
Could you set up a filter on your sequence based on name control _?
Is that just, can I type control _ here? Is that the question?
I think so, yeah.
I think I can type control. It's like, yeah. If you are asking about being able to save those filters, I don't think you can save filters currently in Sequencer.
Yeah, I'm not sure about, if it's possible, but I guess not having just like a button as the other filters in, say, the content browser.
Right, but that does point out something. Since Control Rig and Sequencer both can be driven through Blueprint, you can create editor utility widgets that can do some quick logic. So if you wanted to create a character picker using editor utility widgets, you could absolutely do that and just do some name-based selection stuff that would drive your selection in your report.
Yeah, we've mentioned this before. There's actually several people who have built stuff like that and posted on Twitter, where they're basically using Blutility, like the editor widgets, together with Python. And we've said that before, but I'll just repeat it again. Control rig is 100% exposed to Python, so you have access to the hierarchy. You can introspect what bones exist, what controls exist. You can look at every node and interact with all these things. So if you want to have a custom widget that has buttons where you can click and it selects all the hands, let's say, as a simple example, you can absolutely do that. And there's examples of people building these kind of workflows.
I'm sure we have a few more questions, but I want to make sure that we can talk about 426 because I know it will introduce more questions and it'll answer a few that we had already.
Let's go.
Let's do it.
All right. So let me get my slide back up. All right, looking at 426. Let's start at the top. Helge, what's a control rig component?
It's a component that has a control rig in it. So
Yes.
basically, what this means is that you can add to any actor in your world, you can add a component that hosts a control rig, and then you can drive that control rig and map it procedurally, right? So that might be as simple as mapping the skeletal mesh the way you used to, or it might be add 12 static meshes and drive their transform to the control rig and feed data in and out. So at that point, control rig becomes a function that you can use inside of your blueprints, and then you could do all sorts of interesting logic with this. Do you want to cover earlier question, Jeremiah? There was using a control rig on different kind of topologies or different kind of skeletons.
Yeah. So to add on to this, control rig component allows you to define a control rig and the skeletal mesh to drive. So you can drive different skeletal meshes with different control rigs. You'd be able to introspect, like I think Helge mentioned, you can drive controls through blueprints, you can drive bones through blueprints, and you can also reinitialize those bones in new poses. So this would allow you to deal with proportion changes for different actors, for example. Additionally, since you're able to pull bone values out or control values, you're able to drive static meshes. So this allows you to create rigs that can now drive static meshes without having to do any skinning. A great example of this would be doing a car, for example, and you want to have some doors open, and it's just a bunch of static meshes. You can do that through a control component and an active blueprint. This also, we've had some questions about retargeting between control rigs or driving control rigs with control rigs, and this is where you can start getting into this really cool area of feeding values between control rigs or across blueprints and gameplay logic. So
yeah, we had a question before around VR, right, and solving, given two hand positions and a head position transform or something, solving a character. Now, using an animation blueprint, unless you need the features of the animation blueprint, is a bit too big for that. In the next release, you just can create an actor or your pawn and add the component to it, add the rig to it, feed it the data, and solve for all the other bones, right? So it becomes much simpler. Control rig becomes a part of the toolbox and is no longer caught just in the anim blueprints. You can use it for other stuff at that point.
Yeah. And that way you don't have to rely on parameters if you don't want to. You can just feed the values directly in. Next, let's talk about setup graph real quick. So setup graph is another graph you can create in your control rig. It's another event. And it allows you to initialize your rig before it runs the update event. So in the example that I mentioned earlier, where I have, let's say, 6 characters of different proportions, and I have one control rig, I can reinitialize those controls to be in the correct place for that scale mesh without having to create unique control rigs for each one of those characters.
Yeah, just to clarify, because you said run before the update, it runs only once, right? So the setup graph, it can run multiple times if you use the component, because there you have capability of saying when it should run. In general, though, setup runs once, adjusts whatever it needs to adjust, caches whatever it needs to cache, and then update goes every frame. So topological changes are useful. Sometimes for your custom IK solver, you might want to measure the original distance between the hand and the clavicle, right? You do that in a setup graph. You store it somewhere in a variable, and later you use it during the update. So for simulations, a lot of times you want to remember something for simulations when you start and so on, right? So that's what this is for.
Another great example would be with the VR example. One way that's commonly used so that you don't get hyperextension of the arms is you measure your arm length, holding out your VR controllers. You could do that and then feed those values into your control rig so you never hyperextend your arms. Anything else to mention about control component or setup graph, Helge?
No, that's good.
All right, looping and branching. A little self-explanatory, but we're going to have looping for loops, and you can do for each. You can create collections in a lot of various ways. We're calling groups of things collections. You can do it by name. You could do it by hierarchy. You could do it between two bones. You could say, give me everything that's just under the hands, or give me each finger and combine these collections. So if I wanted to rig a hand, for example, I could say, give me everything under the hand bone and treat this as fingers, as individual chains, and then feed those collections into transformations. Over to you, Helge, because I'm running out of words.
Yeah, that's fine. So do you want to show the biped rig real quick?
Yes.
Can you switch to just showing the biped rig? I'm not even going to go into too many details. So with this feature, we're adding looping branching. Looping means doing something multiple times, right? And branching means switching between different things, either A or B or other paths. A or B switching is really important. It's self-explanatory. It just means you can have features in your rig that are on or not on. You can do it or not do it, and that means you can now build things which react to context, and VR rig that works for animation that will works for VR live, and just build it in a way that it works for both. If you just scroll back, in your rig, just look at the whole thing. Sorry, I mean the graph. That's also nice, but I mean the graph. So in the top, right? So he's doing something there. I think just measuring roughly 7 times. Right, yeah. He's taking control, putting on a bone, taking control, putting on a bone. In the next version, you just have to build this graph once and then loop over the things you want to do this for. So your graph become much smaller. There's also another benefit. In case there was another bone intermediate, because your rig has changed, your skeleton has changed, now you just have to change what the loop is running on instead of having to build the graph. And the reason I said bit of a hint for fingers are a really good example of this, because you have a lot of chains that are all similar, and you would do the exact same thing 10 times or something on your character, then looping is your friend, right?
Yeah, and it gets into a place where you're constructing runtime rigs or animation rigs dynamically based off of some sort of dynamic collection. Let's go with that.
Yeah, let's stop there. Can you go back to the slide?
Yes. Backward compatibility. We've had these questions a bit before. Hopefully this live stream illustrates that Control Rig's not going anywhere. It's currently marked as experimental, but we're fully supporting it. And as we go forward, we're adjusting nodes that's as we find better ways to do things. So when we get into 4.2.6, you may see a lot of nodes may be deprecated, but they're deprecated, they're not removed. So your rigs won't break. If you develop things now, fingers crossed they won't break. If we create things now, there should be a path forward. And there's going to be the better way to do it, but everything should.
Yeah, I mean, we're using self-deprecation paths, so we're not going to break your content. Control Rig is fully supported and is a big initiative for us, so we are investing in it. The reason we want to show you a bit of 4.26, we usually don't do outlooks, is just because there have been a lot of questions around, should I invest in this now? Should I use it from animation? Should I wait? And it's a major initiative for animation. Go ahead, test it, use it for your stuff. It's a fully supported feature.
There was a question that came up, which was when will Control Rig not be experimental?
Fortunately, we can't answer that, right?
Nope.
You have time for a couple more questions?
We got a slide for questions.
Look at that.
Yeah, let's do a few more.
Do you have any examples of inverse kinematics, forward kinematics blending? So if you wanted to sometimes use inverse kinematics and blend to forward kinematics during a clip.
We don't have an example of that up. But I tried to illustrate quickly how you would go about doing that by driving the weight parameter of a basic IK. Yeah.
I'd say maybe we can try. No promises here, but maybe we can try. As we update within future versions, we update the Mannequin. Start adding more features into it. And there's obvious things that we want to do there, but maybe we can try to do that for either the arms or the legs to illustrate in a simple way. I don't know. Again, no promises here, but we'll take note.
Yep.
Let's see. Can you build your own custom script-based control rig node in Python and or some C-like optimized language?
You can create your own custom rig units using C++, but you can't construct nodes using.
Yes. So we focused on making it really, really easy to build units. So I always suggest that if you're curious about this, take a look at the source code. Under the control rig source, there's a folder called units, and that's where all our units are, all the rig units are. And they're very simple to implement. So for anim graph, this is maybe where some people are coming from. We had like 2 or 3 classes you'd have to build: runtime version of the node, editor version of the node, edit mode, and a bunch of those things. And there are reasons for that. For control rig, we went for a simpler path, which is you build a struct. The struct properties are the pins you'll see in the node, and then there's one function you have to implement for the execution of the node to make it really easy for people to build those. So yes, that's C++, but we've had a bunch of people giving us feedback saying, I have these 3 transforms coming in, I have some other setting, and all I want to do is do some custom math with that. That's not, for that you don't need a 101 primer for C++. You can probably still turn that around if you're willing to learn a little bit. And a lot of the nodes that we have are simple like that if you look at them. So it's a good resource for learning. You can use Python to build your graph. So if you want to orchestrate using Python, say like create these 3 nodes and wire them up this way, because that's what I need, you can do that with Python. So while I know that's not a yes to your original question, there's these 2 paths for you to look at this stuff.
Let's see, there was another question about physics. We already covered that. Can you control animation keyframes / tangents using other control rig node to drive or change?
I think we had that one.
I think we did that one. Okay, there was a double there. Yeah. Is it possible to make IK with constraints or limits in control rig? I see that you can probably set that up using just sort of compute that data, right? Like clamp in this range, use a map range clamp or something. And I guess that would be the approach then.
Yeah.
Yeah, go ahead, Jeremiah.
I was just to say, if you're looking for a simple one and done node to do that, I don't think we have a node specifically for that scenario, but you can do the calculations.
Also, one of the things we didn't show, and we're not going to show, I think, because we're running out of time, is you can set controls, right? And this seems a bit strange. So you can, for example, have your hand control drive your bones, and then you might have moved the control too far away from your arm, right? So you want to constrain, or you want to constrain something else. What you can do after you've solved the bones is set the control again to correct it. So if you say the control can never go further than this place or closer to this bone or whatever your logic is, then you can just set it. And in the animation experience, what it will be like, you'll move your control freely until you reach that, and then the rig will correct where the control is afterwards. It's a bit of an interesting workflow because that's not possible in other systems, but because you have this stack where you can just change things one after another, so solve the bones using the control and then move the control again to limit it, you can come up with some interesting solutions there.
Trying to catch some of the new questions that came in here. We tackled that already.
I have a hard stop in 7 minutes.
All right. Well, if that's the case, I think this is a good time to end it. I will make sure to provide you guys with all the other questions that came in case there's something that you'd like to tackle afterwards. If you're looking for those answers, go ahead over to the discussion thread, which is on the Unreal Engine forums. That's where we post all of the upcoming live streams and follow up afterwards as the video lives on in perpetuity on Twitch and YouTube. With that said, thank you guys so much for coming on. Before we leave, I did want to take the moment to let everyone know that we covered a lot of stuff today, which you might know if you spent the entire stream with us. Thank you for sticking around. If there was something during the stream that you don't remember exactly what timestamp we were talking about, we do add transcript for all of our live streams on YouTube. And so in about a week to a week and a half, depending on how long the streams are, we upload the transcript in the YouTube description, and we have the timestamps in that transcript right next to what was spoken. And so right here, right now, this will be transcript. And if you go look at it, it will be at like the 1 hour, 55-minute mark, or roughly. And then you can actually, Control F in the transcript, find the terminology you're looking for, get the timestamp, and then go and watch the video and find that. It's a nice little tip. I think we have transcript for almost the past, at least 2 years of live streams are available. So you can go check that out. Good little tip. We're still looking for new countdown videos. In case you've been following us from the beginning, we do a 5-minute countdown video. That is 30 minutes of development from your project. Go ahead and speed that up to 5 minutes and send that to us together with your logo, and you might become one of our countdown videos. As always, we're looking for all the projects and amazing things that you guys are creating out there. And so make sure you let us know on the forums. There's a good release channel. You can also hit up our unofficial Discord channel, Unreal Slackers, and or you can just you can PM us on Discord, or release forums are a good place though, and then others can come in and chime in and look at what you're doing. It's all good. Make sure you follow us on social media. If you're curious about the upcoming live streams, we do have the schedule listed on Twitch. It's a little short right now, but there's more coming there soon. And I think with that said, thank you guys so much for taking time out of your day to come on and talk to us about these amazing new tools. I'm excited to see what the community comes up with in terms of using them. Make sure you do let us know. Post in the thread for the live stream itself, or on the work in progress section on the forums. That's also another good little shout out. I think we might end up doing another one at some point. It seems like y'all are working on some new things that we might be able to cover in the future. How does that sound?
Yeah, sounds great. This is really, really fun. Thank you for setting that up, Victor, and it has been a great experience. Looking forward to the outstanding questions on the forums and ongoing discussions. It has been very rewarding to see what people come up with on Twitter and other places, so I'm looking forward to feedback from the community. And yes, I'm totally up for doing another one, and Jeremiah has been forced to do it with me, so there's no no here.
Yeah, I'm looking forward to it.
Awesome. With that said, I wish you all to stay safe out there, and we will see you again next week. Bye, everyone.